not sure that this is the problem in the book, but this is what I have written down.
Wait, which problem? You're trying to do 2.2 number 1?
Yeah.
Okay.
I wish
I
they
know
would have
I
asked me
found
this
something
problem.
after I solved it
So
one
I
step.
did this problem
And right
instead.
You know how you told us we could
This
change
is her
it if we
writing,
don't like it? She just changed the whole problem.
I definitely did not say that.
Yeah, so the original problem is y prime equals the right side over y minus 2, by the way.
Oh.
Okay, so
Well,
she
this is
multiplied
my
both
first
sides
step.
by 1 minus 2.
And then I guess if I want to make it a bit longer,
Rather than just giving us the answer.
You show work, what?
okay,
Here's the
then.
problem, here's the answer.
What? What?
Wait,
What?
guys,
Whoa.
something happened.
No. Whoa.
You made fun of her, and now she's destroying you by just writing down the answer.
No, this isn't the answer.
Joe, you silly goose.
It's not, that's like the completed square version. She already
I don't
did
know
it.
if that's...
It is. And
Did
then you
really
multiply
just
by
do those
2 and then you do the
steps?
square
Was
root.
that actually your steps?
Yeah, she actually
Like
did a
that.
clever thing.
I got something
Not quite,
different.
but close.
Yeah.
You super had it, and then...
I think you have to subtract something somewhere,
Okay, so I think you had...
right?
That's be like 2 plus or minus something.
Okay, so she started with this, and then she separated, right? So to throw in steps here, she had y minus 2 dy is 3x plus, or 3x squared plus 2x plus 1 dx.
Sure.
And then she had to integrate, and you all were like, oh, I know how to integrate y minus 2. It's y squared minus 2y,
Y squared over 2.
right? And what she did is, she said, okay, instead I'm going to do a u substitution. I'm going to let u be y minus 2, and then du is dy. And so then this is the integral of u du,
Sure.
which is u squared over 2,
Sure.
which means you get a y minus 2 squared over 2 equal to, and then you just integrate the other side. So you got x cubed plus x squared plus x plus a constant. And now you're asking, whoa, wait, mine is different than that, right? Because you all ended up with a y squared minus 2y.
Right.
And the difference is in that arbitrary constant.
That's dumb. Who builds this stuff?
I got something slightly different, even if you solve the y.
So if you solve for y here, you multiply through by 2, right? So you got y minus 2 squared. This is why you were asking me about arbitrary constants.
Yeah.
Yeah, that's cool. So you got 2 times x cubed plus 2 times x squared plus 2 times x plus a constant. This constant is twice the other constant, but who cares because it's a constant. And then you square root both sides.
And then add
And this is where I'm.
You still need
This
the
is where
two,
you're just a
man.
little bit off. So you got y minus 2 is the square root of this stuff.
Oh, then do you add the 2 outside of...
Right.
Yeah, so the c is in there, and then when you add 2, it ends up on the outside. And so you
Oh,
can't
okay.
add that to the arbitrary constant because the arbitrary constant is square rooted and added to some other crap.
That makes sense.
But yeah, that was actually very cool and slick.
So,
The other option, right, so the branch that you guys took was the y squared minus 2y is equal to whatever,
yeah.
some function of x. And then you had to
One
complete
half.
the square on both sides, which is a good technique to know, but it gets you back from here.
So I got my final answer was y equals 2 plus or minus 2, the square root of 1
Yeah,
minus
you're
x cubed minus x squared minus x plus c.
Yeah, you're wrong.
How? So confused.
Ditto.
I feel like I did everything right.
Transcription error? I don't know.
Because I got what Anna got.
Yeah, I think
Well,
me
what
and Gabe
Anna was
got
supposed
what
to
Anna- I think me and
Yeah,
Gabe got what
we
Anna
got
was supposed
two.
or got to yesterday.
Yeah, as I recall, you guys were here pretty
Yeah.
quickly yesterday.